Statistics. An introduction to statistics is normal distribution. It's a curve that is symmetrical and bell-shaped and has a mean and standard deviation. The symbol for mean is mu, and the symbol for standard deviation is sigma. An example of normal distribution is the empirical rule. Within one standard deviation, there is 68% of the data. Within two standard deviations, there is 95% of the data, and within three standard deviations, there is 99.7% of the data. Calculating using empirical rule. So an example is, the scores on an exam are normally distributed with a mean of 85 and a standard deviation of 5. What percent of scores are from 85 to 95? First, draw a bell curve with the empirical rule, and then you can tell that between 85 and 95, the percent values are 34 and 13.5%. Add the percents together, and your answer is about 47.5%. Probabilities using a calculator. To find the probability without using empirical rule, go to your calculator and do second vars, normal CDF, and then type in your lower bound, upper bound, mean, and standard deviation. An example is, the scores on a test are normally distributed with a mean of 80 and a standard deviation of 2. What percent is between 79 and 83? So first you would draw a bell curve, and then you go to lower, which is 79, because it's the lower value. Upper is 83. The mean is 80, and the standard deviation is 2. Then you get your answer, and to get a percent, you would multiply by 100, and your answer is 62.466%. Calculating using boundary points and percent and areas. To find the boundary of something, which is the number, you would do second vars, go to inverse norm, and type in your area, mean, and standard deviation. To always think of the left tail area. So scores of a test are normally distributed with a mean of 72 and standard deviation of 2. What score must you get to be in the top 30%? Because 30% is the right tail area, you have to think left, so it would be 70% because 100 minus 30 is 70. So you would go to second vars, go to inverse norm, and then you would turn all percents into decimals, so it would become 0.70. The mean is 72, and the standard deviation is 2. And then paste, and your answer is 73.05.
Next, we have z-scores. We can standardize scores that are normally distributed by converting it to a z-score. So this way we compare the SAT and the ACT. So here's the equation, z equals x minus mean or average divided by standard deviation. And here's an example. Here's another example that you guys can try. So here are the different types of sampling. So first we have systematic sampling, and it's a fixed periodic interval with a random starting point. Next we have simple random sampling, which where the population has the same probability of being selected and the sample size has the same probability of being selected. Next we have stratified. So this highlights specific subgroups, and it divides the entire population and randomly selects subjects from the data. Next we have cluster sampling. So this sampling is where the entire population is divided into clusters and randomly sampled. Next we have convenience sampling. So subjects are taken from a group that is conveniently accessible. And then finally we have voluntary response sampling, where subjects select themselves in order to be part of the study. And here are 2 examples of sampling that you guys can try.
Types of bias. Undercoverage bias is members of population that are inadequately represented. Non-response bias is individuals chosen are unwilling or unable to participate. Question wording bias is wording is confusing or misleading. Response bias is false or misleading answer. Voluntary response bias is sample members are self-selected. An example, 15 people volunteer for a survey. That would be voluntary response. 5 people change their answer to sway a vote. That would be response bias. Experimental versus observational. Experimental is manipulation and measure response variable. Treatment is imposed, while observational is data is observed and collected and there is no manipulation. An example, a doctor watching a patient after administering an injection. That would be observational because the doctor is doing no manipulation.
Population versus sample. A population is all subjects of interest. For example, that would be all students at Greenoak. A sample is a portion of the population. For example, 1,500 students at Greenoak. Here's a diagram of population and sample. Parameter versus statistic. A parameter describes the entire population. For example, 12% of all males in the US are illiterate. That would be a parameter because it describes all males in the US. A statistic describes a sample. For example, 8% of 1,500 males in NC are illiterate because it describes the sample, which is 1,500 males in NC. Expected value in fair games. Expected value is the weighted average of possible outcomes. This is the formula right here. A fair game is a game where the cost is equal to the expected value. For example, you pay $3 to play a card game, where a spade is $10 and anything else is 0. When the expected value is not the same, it is not fair. You try.